Welcome to Brain Vision.
Let's say the location vector of Earth is vector E. We are given this is 0.3182 I hat plus 0.9329 j hat. Notice that the k hat is absent because our xy plane is defined to be on Earth's orbital plane, and hence Earth's z component would always be 0. Now, the location vector of Mars is given as 1.3087 I hat minus 0.4423 j hat minus 0.0414 k hat. Now, for part A, we need to sketch this diagram. Let's, as usual, choose x-axis horizontally and y-axis vertically. This is our sun. For Earth, we have a small x component and a very large y component, both of which are positive. Hence, we expect it to be in the first quadrant, and we expect it to be something like this. Whereas for Mars, the x component is large and positive, and the y component is small and negative. And hence, you expect it to be something like this. Hence, this is Earth and this is Mars. Of course, the Mars is not in this plane, it is slightly out of this plane, but we will ignore that for now. Now, we need to find for part B the distance of Earth from Sun. Now we know that this is vector E and this is vector M. Hence, the distance from Sun to Earth would simply be the magnitude of the vector E, which is square root of 0.3182 squared plus 0.9329 squared, which is, notice that all of these numbers are in the units of AU, astronomical units, and this number turns out to be 0.9857 AU. Similarly, the distance from Sun to Mars would be square root of 1.3087 squared plus 0.4423 squared plus 0.0414 squared, which is 1.382 AU. Notice that because we are given 4 significant digits here in all numbers, we are expressing our answers also in 4 significant digits. Now we want to find the distance between Earth and Mars. So let us consider the difference vector m minus e, which would look something like this. Now we simply need to find out m minus e, and m minus e would simply be 1.3087 minus 0.3182 I hat. Notice that I have subtracted the x component of m from e component of x component of e from the x component of m. Similarly, for doing the same for other components, we can write it as minus 0.4423 minus 0.9329 j hat plus minus 0.0414 minus 0 k hat, which turns out to be 0.9905 I hat minus 1.3752 j hat minus 0.0414 k hat. Hence, the distance between Mars and Earth would be the modulus of this vector, which would be the square root of 0.9905 squared plus 1.3752 squared plus 0.0414 squared, which turns out to be 1.6953 astronomical units. Now we want to find out the angle subtended by Sun and Mars on Earth. That is, we need to find out this angle. Hence, if we take this vector and this vector, we can find their angle using the formula. We know that angle between vectors A and B is A dot B by cos inverse of A dot B by mod A mod B. Now we know that this vector is simply minus E because we know that E is like this and minus E is in the opposite direction. Hence, our A is minus E hat dot, and our vector B is M minus E by mod E mod M minus E. Now this turns out to be cos inverse of, we know that mod E is simply 0.9857 from here, and from here we can see that mod M minus E is simply 1.6953. And now we do E dot minus E dot ME. First of all, let's write down minus E. Minus E is equal to minus 0.3182 I hat minus 0.9329 J hat. Hence, minus E dot M dot E, M minus E, would be product of the X components, which is minus 0.3182 multiplied by 0.9905 plus the product of the Y components plus the product of the Z components, which turns out to be cos inverse of 0.5791, which is 54.61 degrees. Hence, this angle is 54.61 degrees. Now we want to see if moon would be visible at midnight on this day. Now, if you are standing on the Earth here, any star that is here, you would not be able to see because Earth would obstruct your view. Whereas any star above this line, you would be able to see because there is nothing in between. Hence, for you to be able to see Mars would have to be, if you draw a line perpendicular to the Earth vector, Mars would have to be above this line, which is not true in this case because this angle is less than 90 degrees. Hence, you could not have seen Mars on that day. I'm sorry. This angle needs to be more than 90 degrees for that to be positive, for that to be possible. And it is not more than 90 degrees, and hence you will not be able to see Mars on that day at midnight.